Hello my dear students, welcome everyone to India's first animated live tuition. I welcome all of you to 90 plus my tuition app family. So guys, please do get ready over there. Let's begin a brand new session. So let's discuss the core concepts of refraction. You guys will be thinking, why the dinosaur is stuck over here? Don't worry, we are gonna make him move. So you guys will be thinking, oh, the dinosaur is stuck today. Today the dinosaur also will be more energetic, don't worry about it. So we'll be discussing the core concepts of refraction. So in the previous session we have checked out what is refractive index. So in detail we'll be checking out refractive index, and also we have learned you guys just got an introduction of optical density, right? So we'll be discussing optical density as well today, so please don't forget it. So once you guys are ready, please do let me know. So please do let me know, sir. Yes, sir. We are ready for a brand new session. Give us some tough topics, core concepts, real quick. Fine. So anyone, any queries, doubts, concerns before we start? Real quick, go ahead. No doubts, no queries, no concerns. Yes, good evening everyone, good evening. So everyone is energetic today, right? Smiling faces, yes sir. Let's learn everything in an interesting way for sure. So today we have Kiran sir and Anup sir as our host, and we have Shweta ma'am as our support tutor. So everyone wave to our team. We have a student coordinators team, host, support tutor. So a big bunch of team is working behind, not just the tutor who comes in front of the camera. So guys will be like, yeah, Manoj sir puts all the effort. No, I'm just giving you the concepts. I'll be like delivering it to you. So guys, this is how we get refraction. This is how the light comes. There are some people working behind, right? How are you getting the animations and all? How is this dinosaur moving over here? Because of the animations they do, right? So is it the actual dinosaur coming in your way? No, right? So it shows chemistry teacher at the bottom. Okay, Kiran sir is like, Kiran sir, everyone make faces? Fine. But you are a physics teacher. Fine. Thanks for making it remarkable. Thanks for letting me know about it. Yeah, fine. So everyone get ready. Devananda, can you please tilt your camera a little bit down? And everyone, when you are in the session, keep your camera in such a way that I can see your face properly, and also a little bit of your notebook as well, so that I get to know that you are writing as well. Anyways, don't keep it like this. Sir, you can see me as well as my notebook, selfie stick. No, don't keep your mobile or the device which you're using like a selfie stick. Don't do it. We are not FaceTiming, right? So once you have a doubt, please don't forget to raise your hands and ask me directly, or else you can drop your queries in the chat box. And also I used to say, right, keep what? Keep a bottle of Boost or Horlicks, no, right? Energy drinks, you can keep just a bottle of water, fair enough. Okay, so that what is the advantage? Okay, if I keep a bottle of water, I can do some weight presses. It'll act like dumbbells, right? You can do workouts and all. Yes sir, today we'll have some workouts with water bottle. No, actually it'll improve our concentration when we'll do workouts, right? When we have a sip of water in the meantime, when you are learning something, so your brain will be like, bro, I got enough water, so I'm hydrated, so you're not making me dehydrated, so I'll be more active, I'll give you more focus to learn the concepts. So not just during the session, whenever you're learning something, keep a bottle of water with you, so that you guys can get yourself ready, you guys can improve your concentration as well. So in the previous session we have checked out this table, that is the different material mediums which we are considering, and we have considered the refractive index values of it. Okay, so from the beginning we have checked out air, so the value of refractive index was just 1.003, and in the case of diamond, how was it? The case of diamond was 2.42. In the case of air, it's just 1.003. So there is a big significant difference, right? In the case of refractive index, always will be decimal differences, but you can see that 1 and 2.42. In the meantime, all other material mediums will have a different value. So the intensity of it comes from rarer to denser, right? Diamond is more denser compared to that of air. I hope you know that. Got it? Fine. So please do keep that in mind. And also we are going to go ahead with the next topic, that is none other than optical density. So what comes to your mind when you hear this term optical density? Optics means what? You know what is optics, right? The involvement of photons or light in a particular medium, that is optics, right? What is optical density? Optical density is a measure that shows how a medium influences the speed of light passing through it. It means that how much denser particles are packed in a medium which will allow the light to pass through them. So for example, if we are considering a particular optically denser medium, okay, optically denser medium, which means that more particles are influencing, or more number of particles are influencing the optics through it. So it is very denser. That medium is denser and optically it's influencing more, which means the speed of light will be decreasing as the optical density increases. So that is, they are inversely proportional. That is, as the optical density increases, the speed of light decreases in that particular medium. If a medium is optically denser, it means that more particles are disturbing the path of the speed of light. So the speed of light will be going like zigzag, like some random frog and all. So like the dinosaur which we have seen, dinosaur will not move according to our wish, right? Straight path and all. So in the case of optical density, if it's not optically denser, the speed of light will be greater in that. So it is inversely proportional. So as the optical density of a medium increases, the speed of light decreases. So that is the difference. Optical density of a medium increases, the speed of light will decrease. So if you think about the inverse relation of speed of light and optical density, you will understand the concept of optical density. Got it? How to get the concept of optical density related with the speed of light? Understand that as the optical density of a medium increases, the speed of light decreases. So that you will understand the concept of optical density, that is, it is a measure how much denser is that medium. It's a measure that shows how a medium influences the speed of light passing through it. Clear? Clear? Hi guys, is it clear? So everyone is like, sir, don't act smart. You know that we are all on mute and still you are asking. You guys have some gestures and all, right? Give me a thumbs up. Or like, yeah sir, we got it, fine. And you can do jingle all over there. Yes sir, I got it. Nashwa Fatima looks so serious today. Sir, what is this optical density and all? I didn't get it. Unmute Nashwa Fatima. Yes. It's right in front of Shweta ma'am. In the middle. Yes. Yeah. Shweta ma'am is like pinpoint. Sharpshooter. Yes, I got Nashwa Fatima. Hi Nashwa, are you there?
Yes, sir.
Fine. So Nashwa, did you understand the concept of optical density?
Yeah.
You got it, right? If the optical density of a medium increases, what happens to the speed of light?
It decreases.
If the optical density decreases, the speed of light?
Increases.
Increases. Fine. Understood the concept perfectly, right? Don't be like, yeah, since sir asked, right, he will feel bad if I say no. So I'll say, yeah, I got it. Not like that, right?
No, sir, I understood.
You got it, right? Fine. So, be like Nashwa, be very honest. Don't be like, yeah, the tutor will feel bad. He explained, he took a lot of time for the concept, and now I'm saying, sir, I didn't get it. You can ask it right away. Not later on. When I reach the end of chapter, no, don't ask, sir, what is this optical density? I'll remove you from the meeting. You can just say, sir, now I didn't understand. Before you go ahead, can you please make it more clear with some examples or something? I can do that. But don't be like, sir, I can't understand. Or since you asked, I said, I got it. So can you explain? Yeah, who was that? SA. SA is confused. Who is that SA? Ansh. Hi Ansh. Please unmute yourself. Hi Ansh. Are you there? Where is Ansh?
Yeah, here.
Okay. So Ansh, can you hear me?
Yes, sir.
Twinkle, twinkle, little star, how I wonder what you are. Up above the world so sky. Okay, I forgot the rhymes. So, Ansh, over here, what are we doing? Did I consider some biscuit box or something? I considered a medium. Okay, I am considering a medium. So, in that particular medium, suppose there are some particles. Okay, we'll consider Kiran sir, Shweta ma'am, and all. Okay, lot of unwanted particles. Shweta ma'am, Kiran sir, Shweta ma'am, Kiran sir. So like that we have lot of unwanted particles. So what are we doing? It has some unwanted particles or the particles which disturbs the optic property of it or which disturbs the speed of light or the path of movement of the light in that particular medium. So, yeah, so which it means that that particular medium which I am considering is optically denser, which means the number of particles which influences the speed of light is greater in it. Got it, Ansh?
Yes, sir.
So I can say this particular medium which we are considering is optically denser. Got it, Ansh?
Yes.
Got it? If I say this medium is optically rarer or the density of it is less, it means that the light can travel through it easily because there will not be much unwanted particles. There will be good particles like Manoj sir and all. Got it? Got the concept?
Thank sir.
Yeah.
Yes, sir.
Fine. So that is the concept of optical density. Now everyone got it, right? So since I gave very good examples, you guys were able to understand it. So I do know that. Fine. Thanks for your support. Kiran sir is like, that's the end of the day. You can just teach the concept. I won't give animations and all. Shweta ma'am is like, even if you ask me, I won't unmute anyone or I won't give answers in the chat box. I won't be your support tutor and all. Guys, I asked you in the previous session itself, you guys are on the side of Kiran sir and Shweta ma'am or me? You want your tutor or support tutors and host? Or student coordinators? Whom you want? Which team are you in? Team A or B? Team A is my team. Team B is Shweta ma'am's team. True. Reemshay is like true. How many of you are in team B? How many of you are in team A? Team A is my team.
Abdul is on
Team A.
B, sir.
Abdul is like AB. What is this? Absent? Mohammed Shah is like, of course you sir. There you go my boy. I love you. Rihan is like none of the above. Rihan, this is not your multiple choice exam time. Both hands clap, only sound will come, right sir? So both philosophical theories coming up. So guys, we got the concept, right? Got the concept? As the optical density of a medium increases, the speed of light decreases, which means if there is more denser, if the medium is optically denser, the speed of light will be disturbed. The speed of the light won't be able to travel through it easily. So the speed of light decreases in that medium. So I hope you got the concept. Let's check out a question. Can the media given in the table be arranged in the increasing order of their optical density? So everyone is thinking, where is the table, sir? Please bring a table. So you guys want a wooden table or some aluminium table? Which one? We will take this simple table of air, glass, water and diamond. So you have to arrange it in the ascending order, right? So can the media, these different types of like one or more mediums is termed as media. So given the table, that this is the table, this is supposed to be, I'll write, this is supposed to be table. Okay? Be arranged in the increasing order of their optical density. Increasing order of their optical density. Can someone help me out? Air, glass, water and diamond. Or air, water, glass, diamond. diamond, air, glass, water, or water, air, glass, diamond. Which order should I write over here? Which medium will be more optically denser? More optically denser will be written over here in this side. Less optically denser will be written on this side. Increasing order of their optical density. So which medium will have the maximum optical density? Let me know. In which medium will have the speed of light very less? Share your answers in chat box real quick. You don't have to raise your hands. You can drop it down the chat box. So keep your hands raised for my students who have doubt. Have a doubt, you can raise your hands. Others, please lower it, or else I'll assume you guys have big doubts. Yes, who was that on top?
Abdul.
Hi Abdul, are you there?
Yeah.
Yes, what's your doubt? Go for it.
No, I like the answer.
You wanted to answer, I told you. Those who have a doubt, you keep it raised, otherwise lower it. You can drop your answers in the chat box, but since I have unmuted you, you are so lucky enough, now you can answer. Go for it.
First is air because it has less density.
Okay, less optical density or greater optical density?
Less.
Less optical density means, what about the speed of light?
It will be more.
Speed of light will be more in it for sure. Fun. So next, diamond, right? Second one.
Next is water.
Next is water. So next is water. Fine. Then after that,
Glass.
after that, glass. Cooling glass or what? Or shade glasses or what?
Normal glass.
Normal glass. Fine. Then diamond.
Yeah, next diamond. Yeah.
Next diamond, because only diamond is left, we can't write some what we say Pepsi and all, right? So anyways, it's just diamond given over here, so it will be diamond. So did you understand why did we write diamond in the end? Who was that? Abdul?
Yeah.
Why?
Because it has more density.
It has more density, more optical density, which means the speed of light.
Slow.
Speed of light will decrease or will be slow. Fine, fair enough. So let's rearrange it and check it out. Yes, there you go. So air, water, glass and diamond. So the important part is, it is a previous year question. Very, very important. Note it down. Can the medium given the table be arranged in the increasing order of their optical density? So different medias will be given. So you have to arrange it in such a way that in the ascending order of the optical density. Less optical density for air, greater to diamond. Yes, very good. Some of you have answered. Most of you have answered in chat box. Very good. My chat box is filled with answers. Parth. Unmute Parth. Where is Parth? Hi Parth. Please do raise your hand. Fine. So Parth, less is glass and diamond. Less optical density or lesser speed of light? Less speed of light in the case of glass and diamond. Over here the question was for optical density, right? So you have to write least optical density for air and water. Don't write less glass and water. What is this? Okay, very less amount of water, very less amount of diamond. No, right? So less amount of or less optical density for air and water. Fine. Any doubts? Any queries? No, right? Fine. So everyone done writing it, noting it down? Quick. Once you're done, give me a thumbs up. Once you're done, give me a thumbs up. Quick. Quick, write it quick. If you're not writing it quick, no, I'll sing songs and all. I'll sing Baba Black Sheep, have you any wool? Yes sir, 3 bags full. So if you don't want this ridiculous rhymes, You have to write it real quick. One for my master. One for what? One for whom? I'll give to Parth. One for Parth. So guys, done or what? If you want to escape from my song or rhymes, please do note it down real quick, or else I'll start singing till the end of the session. Okay, I just sang this nursery rhyme in school today with my friend Amelia sharing. Fine. Done, everyone? Can I go ahead? Fine. Everyone done? Once you're done, please do let me know. Yeah, fine. So let's go ahead with the concept of refraction of light. Everyone will be thinking we learned about refraction itself, right? So when a ray of light entering obliquely from one transparent medium, obliquely means what? Who will answer? Obliquely means what? Light is entering obliquely. Raise your hands. What is this obliquely and all means? Yeah, Shweta ma'am.
Yeah.
Down there in the left hand, left
Name
top
please.
corner. Yeah,
This
hand
one?
raised.
Okay.
Yes.
Muhammad Nurul Ahmed.
Muhammad Nurul, what is this when a ray of light entering obliquely?
So it means like when the ray passes like in a way that creates equal angles with the normal.
So it is making a particular angle with the normal, right? It won't be incidenting through the normal. If it makes an angle with the normal, we can say the light is entering obliquely, isn't it?
Yeah, so it's
Yeah.
like equal with the angle.
Exactly. So the thing is, if we mention the ray of light is entering obliquely, it comes with a particular certain angles, not directly like 90 degree. You can't say 90 degrees also an angle, or it's making 0 degree angle, it's also an angle. No. Obliquely means it obviously makes an angle, oblique angle. You guys know it? So everyone is like, sir, we just learned acute angle, obtuse angle, and now what is this oblique angle? So if it makes an angle, you can say the ray of light it's entering obliquely from one transparent medium to another. So why it's mentioned transparent medium, guys? We can take opaque objects, right, or opaque medium, right? Why not opaque medium? Why we are taking transparent medium? For refraction to happen, obviously the light should pass through it, right? So that is why we are considering a transparent medium. So the light should pass through it. So that's why we are considering transparent medium to another. From one medium to another it's going. We have checked out the example. Its path undergoes a deviation. So when we are considering a medium, so what happens? With respect to the normal, it will undergo deviation for sure. It will have a particular deviation with respect to the normal. If you are considering a rarer and denser medium. So obviously its path undergoes deviation at the surface of separation. This is the surface of separation. So over here it will undergo a particular deviation. So don't forget about this surface of separation. That is very, very important. So in general, you can note it down. Note it down. When you define refraction of light, you can write this down. When a ray of light entering obliquely from one transparent medium to another, its path undergoes a deviation at the surface of separation. This phenomenon is termed as the refraction of light. So till now we were just having the introduction part of it. Now we are on the core concepts of refraction of light. We are getting into the core part of it. So now register the concept of refraction of light into your mind. Yes, very good. Some of you are sharing. If we didn't consider a transparent medium, the light would not pass through it, or light cannot pass through it. It can't go through solids. Very good. Achal Krishna is sharing. Obliquely means sideways at an angle, for sure. Very good. Guys, write it real quick, or new song is coming, new rhymes are coming. Write it real quick. I'll soon sing some weird songs and all. You guys will run from my session. If you really want to study something, write it real quick. And if you didn't get the concepts, you can ask me so that I'll be engaged with interactions. If I'm waiting for you guys, I'll sing.
Sir,
You guys have to tolerate me.
Indian says sir, please do sing.
No. Rihan P. Shahjahan, it'll have a particular angle, it'll make a particular angle to the sideways. Is it clear? Where is Rihan? Is it clear? Rihan ran away or what? Asked a doubt and ran away. Rihan, is it clear? Show me a good thumbs up. I saw your head. Okay, Rihan is like, show it like this. Yeah, fine. Show some energy. You're working out during the session as well, right? Fine. Everyone done, I guess? Yeah, Sridhya wants the diagram. Sridhya, there you go. For refraction, if you need a diagram, if you need an example diagram, you can note this down. Refraction, different media. Over here we are considering the two mediums, that is air and glass. The medium which we are considering over here is air and glass. Air is a particular medium and glass is the next medium which we are considering over here. So please do note it down. Incident ray, the refracted ray, and the boundary, that is the surface of separation. Surface of separation is termed as the boundary. Sridhya, can you please raise your hand? Where are you? Yes. Tilt the camera a little bit down. Yes, unmute yourself.
Yes, sir.
Yeah, did you get the concept of refraction clear?
Yes, sir.
No or yes?
Yes, sir.
In the last session you said, right, sir, I'm figuring out, I need a better clarity. Now you got a better clarity of it? Fine. I told you, when we are discussing the core concepts, when we are proceeding ahead with some examples or concepts of refractive index, optical density and all, we'll have a better clarity and we'll have a discussion over in refractive index today as well. Don't worry. Yes. You can mute yourself. Who was that hand raised?
This one.
Ayan Ahmad. Ayan, Devanarayanan, you guys have a doubt or else you can lower it. If you have a doubt, keep it raised. Ayan Ahmad and Devanarayan. Unmute Ayan Ahmad. Yes, Ayan, what's your doubt? Go for it.
Sir, could you choose the question against
Question? Which question?
the oblique?
Obliquely, that is not a question. That is a definition of refraction of light.
Okay.
So, Ayan didn't get the concept of refraction clear, right?
No, sir, I got it. But I thought this was the question, sir.
Fine. Write it down. It's just the definition of refraction of light.
Thank you.
Yes. Done, everyone done? Jareen, unmute Jareen. Jareen Geo. Where is Jareen Geo? Yes, Jareen Geo has hand raised, I guess.
Yeah.
Yeah, Jareen.
So,
Yeah, what's your doubt?
refraction and reflection happens in the same time, right?
Where? In such cases? In such cases, if you ask me, the light rays are not reflecting, it is actually refracting because we are considering a transparent medium. Do you think in the case of a transparent medium, will the reflection happen or the light will pass through it? Transparent means what? The light will pass through it, right?
Yeah.
So is it possible to have reflection over there? Reflection won't be there, right? What will happen? Light rays will pass directly through it In the case of reflection, what happens? Light rays incident on it and it reflects away or reflects back. So it should be a reflecting surface. But
translucent medium?
translucent medium,
Yeah.
it'll partially pass through it. It'll not undergo reflection. It'll partially pass through it, Jerry. So in the case of refraction, if you ask me with the example, both reflection and refraction won't happen. It'll be just refraction. Clear, Jerin? Is it clear? Yeah. Unmute Anaka. Hi Anaka. Anaka, are you there?
Hi, sir.
Yes.
Yes, sir. I had a doubt. This refraction of light, you said something about the transparent medium.
Yes.
That time my voice was breaking, so I couldn't understand that part.
No, the thing is, that was not the concept. Who was the Jerin asked me a doubt like, in the case of refraction, both reflection and refraction happens, right? No, it doesn't, it's not actually like that. Because in the case of refraction, we are considering a transparent medium, right? So in a transparent medium, reflection is not possible, light will pass through it. So in the case of refraction, only refraction happens, there is no reflection incorporated over there. So that is what I was about to say, or that's what I was discussing about transparent medium.
Oh,
Got it?
okay.
Yeah.
Yes, yes, sir. Thank you.
So everyone done? Quick, or else I will sing a song. Done everyone? Can I go ahead? Fine. So let's go ahead. So if we consider the refraction is the difference in the optical density that causes the deviation. In the case of refraction, if you are considering refraction, what causes this deviation of ray of light? What is the reason for it? It is the difference in the optical density. If you are considering two mediums, for example, I am considering two mediums. We can consider air and water. So guys, which one is more optically denser? Water is more optically denser compared to that of air, right? Which one is more optically denser? Water. In the case of air, it is less optically denser, so the speed of light will be greater. So light will be like, bro, I'm not dense over here, I'm not optically dense over here, I'll go according to my wish. But in the case of water will be like, bro, actually I'm so optically denser, please don't pass easily through me, reduce your speed of light. So light will be like, I can't go according to my wish, so I'll bend a little bit. I'll bend to the normal or away from the normal. So since water is more optically denser, it will bend towards the normal. It will bend towards the normal. So this difference in the optical density. So over here it is less optically denser. This is more optically denser. So this difference causes deviation. So this difference causes deviation is the difference in the optical density that causes deviation in the case of refraction of light. So please do note it down. Note it down, guys. Important. It is the difference in the optical density that causes deviation in the case of refraction of light. Quick, real quick. Some of you are asking the numerical value of speed of light in water. Not mandatory to remember. The only value which you have to remember in your mind is the speed of light in air. That is the general case where you have to apply. That is 3 into 10 raised to 8. And the remaining values is not required because it will be given the question itself. You guys should be aware of the speed of light in air or vacuum. That is none other than 3 into 10 raised to 8 meter per second. Remaining values will be given. If there is a question related to it, the value will be given the question itself. Don't worry about it. Don't be like, yo, God, I have to remember all the values by heart. No, not required. Quick, guys, quick. Once you're done, give me a thumbs up or type down in the chat box. Give me a thumbs up or type down in the chat box. Done. Fine. Who was that? Done 20 minutes ago. Iris Abbas. Fine. So let's go ahead. Refraction in different media. We have considered air and glass already. So we can consider other random examples such as air and water or any other medium. For example, you can consider water and diamond. You can do that as well. Through water, light will pass through, right? And on the other side, you can consider glass or diamond. So if we compare water and diamond, which one will be more optically denser? Diamond will be more optically denser and water will be the rarer medium. Got it, everyone? It's not mandatory that always you have to consider air as the prime medium. You can consider water and diamond as well. But in ideal case, in general case, we'll consider air and water or air and glass. Always air will be like, I'll stand on the top. I'll stand on the top. So that is the ideal case which we are considering, because if we are considering air as the rarer medium, we won't have much disturbances. The particles inside it is not much denser. The particles in the air will not disturb the speed of light. So the light will be traveling peacefully in air. That is why in all the examples you see, we consider air as the rarer medium. So what happens when it is in the case of the same optical density? So imagine we are considering two materials of same optical density. That is air and air. Okay, we are considering air and air. Will it have any refraction? Will it have any deviation? No, right? Because the optical density is same. That's why we have learned this. There is the difference in the optical density that causes deviation. So if the optical density is same, what does it mean? There is no deviation. If there is no deviation, there is no refraction. So someone asked a very good doubt. Who was that? So reflection happens. No, the light ray will travel peacefully without refraction. It will just pass through it like normal. If an incident ray passes through the normal, what happens? It passes through it easily, right? Without deviation. Pass through the medium like this without any deviation. So the same way, if there is a light ray which is coming through two mediums which has same optical density, no deviation will happen. Fine. Who asked that, Shweta ma'am? Very good doubt. Can you please check it? Who asked that doubt? Yes. Sridhya. Fine. Very good, Sridhya. So then how can we see ourselves on a window and see the outside? Unmute Ansh. So Ansh, are you there? So in certain windows you will be able to see yourself, and also you'll be able to see the things outside. So the reason for it is multiple layers will be there. So multiple reflection will be happening over there. Got it? So multiple layers, or it will be coated with a film, or that material will be coated with another layer. Got it? And that is the reason. Yeah, it will pass light as well as it will give the property of reflection for it. Got it? Yeah. Fine. Yeah. Unmute Mohammed Nurul Ahmad. Mohammed Nurul has asked almost the same doubt. So we said that reflection doesn't have, if the object is transparent, then what is this? What if it is translucent? Will it both reflect and refract? If it's translucent, light will partially pass through it, right? But it won't. In the case of translucent material, is there reflection happening? No. Only partial amount of light is passing by. That's it. Reflection is not happening in it. Reflection will happen only in the case of adding one more layer to it, or multiple reflections are happening in one single material. Understood, Mohammed Nurul? Please unmute yourself. Got it?
Yes.
Fine.
Yes, sir.
Fine. So refraction in different media. I hope you got it. Yes, you can mute yourself. Fine. So everyone, regarding the concept of refraction, this is the conclusion we are coming to it. Kiran sir, yes. While entering from air to glass, that is from rarer medium to denser medium, we know that air is a rarer medium and glass is a denser medium. So when a ray of light goes from rarer to denser, what happens? The ray of light will have a tendency to bend towards normal. From from the ray of light goes from rarer to denser. So the ray will deviate towards normal. While entering from glass to air, so glass is more denser, right? Air is less denser. So that is from denser medium to rarer medium. In that case, the refracted ray deviates away from the normal. So in such cases, refracted ray will bend away from the normal. So the refracted ray will be like, bro, I'm going according to my wish. I'll bend according to my wish. Don't ask me to bend towards the normal. I'll bend away from the normal if the incident ray is from denser to rare. That is from glass to air. That is an example. You can consider any other example. You can consider diamond and air. You can consider diamond and water. You can do that. Denser to any denser medium to rarer medium. So one more important thing which you have to remember, the angle of incidence, the angle of refraction and normal are in the same plane. So this comes under the laws of refraction. So you guys can note it down, don't worry. You can write as a conclusion, or else you can write this down in the laws of refraction. In the case of refraction also, like reflection, we do have laws. Yes, unmute. Who was that?
Regin.
Yes, Regin, what's your doubt? Go for it.
So just a doubt, like when like the optical density increases, right? Like so that does that mean like the incidence or like the refracted ray will move closer and closer to the normal?
Yeah, when the optical density increases, the refracted ray will move closer to the normal. Why? Because the medium which we are considering is more optically denser, so the refracted ray will bend towards the normal.
So like comparatively to glass, diamond will have the refracted ray more closer to the normal.
Exactly. Yes.
Thank you, sir.
Yeah. So if you consider the structure or the internal structure of diamond itself, we can understand multiple reflections are happening inside, right? So if you are considering one single ray, what will happen? Only refraction will happen. That is, the ray of light will be bending, and inside the diamond, multiple reflection or total internal reflection will happen. Since the medium is optically denser. Everyone done writing? So then how can we see? Yeah, that's addressed. Fine. Any doubts, queries, concerns? Fine. So guys, note it down real quick. I'll start rhymes. Jack and Jill went up the hills, and what they did? They played football, right? They took a bucket of water and they were playing in the water. No. Any different rhymes? Quick. This last point you can write it later on. Just write these two important points. This one we'll write again, don't worry. Give me a thumbs up once you're done. You guys got the concept, right? Nod your head. Sir, we got the concept. I'll cover it. Please write it only if you got the concept. If the concept is clear, you can write. Or else you are not supposed to write it down. Clear, right? Fine. We'll unmute. Who is that? Who is there on the bottom corner drinking water? Yes.
It's Ritika.
Hi Ritika.
Hello, sir.
Yeah. If a ray of light is incidenting onto diamond and it goes out through water, what will happen? What will happen to the refracted ray?
It will move away from the normal as it is coming from a denser medium to a rarer medium.
Very good. You take 10 points. Fine.
Thank you, sir.
Fine. Yes, we have discussed this, Sridhya, but in a polished way. Now we are discussing it in a detailed way. That is why it's a conclusion of the refraction of light. Not the chapter or not the entire refraction part. This is just the conclusion of the learnings we have done till now, Sridhya. Yes, you have to mute yourself. Yeah, done. Fine. Yes, unmute Advait. Where is Advait? In the right hand, man. Right hand over here in this. Yes. Advait has a query. Yes, which one, Advait? Advait, is it like, sir, I just joined now. I was half an hour late. So can you please explain whatever you taught till now? Did you join the beginning of the session itself?
Yes, sir.
You did, right? You were not late, right?
No, sir. Today I don't have school.
Fine. So I told you, before I gave you time to write, I asked you guys, do you have any doubt, queries and all? So you were processing that, or like in which part do you have a doubt?
Sir, the second one.
Second one, from denser to rarer?
Yes, sir.
Okay. So what did you understand from rarer to denser?
Sir, like if the light is going from rare medium to dense medium, then the reflected light speed of light will decrease.
Speed of light will decrease when a ray of light is incident from rarer to
Rare to
denser.
dense.
So what will happen to the incident ray? It will bend towards the normal or away from the normal. What will happen?
Away from the no.
From rarer to denser, it will bend away from the normal. Is that what you have learned? So you said that you got the first one. Did you notice?
Towards the no.
Towards the normal. So I'll tell you why. So focus over here carefully, Advait. So what are we doing? We are considering two mediums. Okay, we are considering two mediums. Let's consider this as medium 1 and let's consider this as medium 2. So if I am taking an optically rarer medium means what? The particles inside it will not be very closely packed or will not be disturbing the speed of light. So speed of light will be the same, it will not be disturbed by any means. So it will be traveling easily. And at a particular point, it undergoes a particular deviation. Cause of what? Cause of the dense particles inside this. So this particular medium is optically denser. So cause of the disturbances or the tightly packed particles in this particular medium, the light ray deviates a little bit. Where? Towards the normal. Which means, this is the normal which I am considering. Which means, the ray can't move freely in it. So it will be deviating towards normal. Which means it has a tendency to bend towards normal. So what is this normal and all? You'll be confused, right? Why towards normal in the case of optically denser? The thing is, the light ray, if it has more space, it always will have a tendency to spread, right? So have you guys tried normal exercises with torchlight? If you keep a hand over it, if you just remove your fingers, what happens? The light rays will have a tendency to spread over the space it gets, right? So light rays, since it doesn't require a medium, always light rays will be like, I'll spread everywhere. If you give me some small loopholes, no, I'll go according to my wish. So in the case of a denser medium, light rays doesn't have that space. So they'll be like, yeah, I'll just bend towards the normal, which means I'll not spread away from it. So normal is an imaginary line which we are considering. So don't think why towards the normal, away from the normal and all. We are considering the normal as a particular general, what we say, reference line. So that is why in the case of an optically denser medium, the light rays are actually bending towards the normal. It's not free to bend away from the normal or go away from the normal. Away from the normal means what? It spreads easily. Got it? And the case of Advait, are you there? And the case of, and the case of two mediums, which is denser to rarer. If it's from denser to rarer, what happens is, in the case of a denser medium, the light rays will be very restricted. But when it comes to rarer medium, optically rarer medium, light rays have more space, the particles are not closely packed in it, so the light rays will move according to its wish. So it'll diverge more, it'll deviate more. Okay, more deviation happens. So with respect to the reference point of the normal, it'll bend away from the normal, from rarer to denser, and towards the normal from rarer to denser to, okay, so from denser to rarer, away, from rarer to denser, towards. Advait, is the concept clear?
Yes.
Did I mess
Yes,
it up?
sir.
You got it right?
Yes, sir.
Crystal clear. Don't say sir, yeah, somehow I understood something. You got clarity,
Yes, sir,
right?
sir.
Yeah, fine.
Yes. Thank you, sir.
Fine. So please do note it down, guys. I hope everyone is done with it. Yes. Check it out. Away from the normal, yes, for sure. Everyone, once you're done, please do let me know. Once you're done, type done in the chat box. Once you're done, please do let me know. Yes, someone has dropped something in the chat box. Please check, Shweta ma'am. Over here in the right hand, 4 new messages. Yes, scroll down. Done. Fine. So Jarin, please do unmute yourself. Where is Jarin? Jarin, please do raise your hand.
You want him to unmute?
Yes.
So is plasma
Yes. Is plasma?
optically rare?
What do you think? In the case of plasma, will it have more particles in it or what?
I'm not sure.
So, what do you know about the material plasma? Plasma will pass the light through it easily, or will it be a translucent material? Will there be more denser particles in it? What do you think?
Easily?
It'll pass through it easily, right? Which means it is more transparent. The amount of particles packed in it will be rare, will not be denser. So, if you ask me, an ideal case of plasma is optically rarer. And in the case of what we say experimental plasma layers, if you are considering, what will happen? It will have more foreign particles. So, for example, in researchers and all, the plasma layers which we are taking will have much foreign particles present in it. So, in that case, it will be denser. But in ideal case, the plasma will be rarer. Why? Because more light rays will be transparently passing through it. Got it, Jarin? Clear? Is it clear, Jarin? Where are you, Jarin? You there?
Yeah.
Got it? Yeah. Unmute Sridhya. Hi Sridhya, go for it.
So and that plasmas are it has an high power, right? To
High power. Okay, you are talking about the plasma in the blood or plasma in our eyes. He is asking about the material plasma or matter.
Yeah, that's what, sir. So it's powerful thing, right? So it can deviate.
It can, yeah, that's what I said. It can deviate in the case of foreign particles present in it. That's why I said, specifically mentioned, ideal case of plasma will be very transparent. Got it? The plasma which is used in research and all will have foreign particles because it has something which will deviate in it. But in the ideal case of plasma, it will be more transparent. You can Google it. It will be more transparent in the case of ideal case of plasma. But experimental research cases, they will use the plasma which has more foreign particles present in it just because there are other optical photons and all present in it. So that will make that object more denser. That's it. In ideal case, it is rare. Clear? Sridhya? Always we'll consider the ideal case, right? Yeah. Fine. The angle of incidence, the angle of refraction and normal are in the same plane. That is related to the loss of refraction. So let's go ahead with the concepts of loss of refraction. The angle of incidence, yeah. So what about when the light passes through a prism? Honey, we are coming to it. Light which is passed through a prism. So we are gonna take the example of prism for sure. We'll go ahead with it. Don't worry. We have a specific topic itself. It's coming. In which chapter? The next chapter, that is human eye and colorful world. We'll discuss it. So in this chapter itself, for your reference, I'll take it. Don't worry. So in detail, we are going to learn about the deviation or the passing of light rays through a prism. So it undergoes refraction for sure. That is a very good example. Fine. So angle of incidence, angle of refraction and the normal at the point of incidence will always be in the same plane. So as in the case of loss of reflection, we have learned the angle of incidence and angle of reflection and the normal will be in the same plane. In the same way, in the case of refraction as well, we can see the angle of incidence, the angle of refraction and the normal at the point of incidence will always be in the same plane. That is the first rule you have to remember. And with respect to the loss of refraction, we can discuss the concept of refractive index as well. So guys, do you remember refractive index of medium 1 with respect to medium 2? V1, V2, N2 and N12, everyone were very confused, right? So regarding that, I'll give you a simpler concept related to it. That is, so guys, do you remember the term? Okay, you guys have learned trigonometry in mathematics, right? You guys know what is sine, cos, tan and all, right? You guys know it, isn't it, guys? Nod your head. Yeah, fine. So if you're taking a triangle, if you're considering a particular angle of it, okay, consider this angle we are considering. So we'll be considering this particular angle as the opposite side, and this one will be the hypotenuse. So this one will be the hypotenuse. So if we are considering this sine of this particular angle is, we can write as sine theta is equal to opposite divided by hypotenuse. So obviously, you know the formula, sine theta, sine of any particular angle will be the opposite side divided by the hypotenuse. So that will give us the sine angle of it. And in the case of refraction, obviously we'll have the angle of incidence, right? We'll have the angle of incidence with respect to the normal. This will be the angle of incidence. Then we'll have the angle of refraction as well. We'll have the angle of refraction as well. So the sine of angle of incidence, imagine we have an imaginary triangle over here. So if you are considering the sine of angle of incidence and the sine of angle of refraction, it will give us a constant value. So that constant is termed as n. That is a constant, some random general constant. We are referring it as a variable denoted as n. So the ratio of this sine I to that of sine r, ratio of sine of angle of incidence and sine of angle of refraction is termed as a constant, and that particular constant is none other than what? Any guesses? Any guesses? Refractive index. Refractive index. Yes. Okay, Snell's law. Yeah, this is also called as Snell's law. Accidentally, Ansh typed Smell's law instead of Snell's law. Instead of N, he wrote M, and Shweta ma'am is like, it's not smell, it's Snell's. Typo. Yes, for sure. And she's like, yeah, I know it's not smells, it's Snell's law. So if you are considering this constant, that is sine I by sine r, what is this based on? What we are considering sine I by sine r? Why are we taking this ratio and all for refractive index? By using a law called as Snell's law. So as of now, in 10th grade, what is the only thing you have to remember? Based on Snell's law, we are considering the ratio of sine of angle of incidence and the ratio of sine of angle of refraction. So we'll give a constant, that constant is refractive index. So in detail you learn about Snell's law in your higher grades. If I give you the concept of Snell's law right now, it'll be very messy. You'll be very confused regarding the concepts. So as of now, you'll learn about Snell's law in detail in your higher grades. So even if you want it, I won't help you guys. Got it? So the thing is, as of now, the only thing you have to understand is based on the refraction or the concept of refraction, when we apply the Snell's law to find out the ratio of sin I and sin R, will give us a constant. So that particular constant is termed as the refraction. The constant from Snell's law is known as refractive index, not refraction, refractive index. So this sin R by sin R, the ratio which we are considering is known as Snell's law. Based on this law, we are getting a constant. That constant n is termed as the refractive index. Fine, note this down. So you just have to remember, okay, this ratio of sin I and sin R will give refractive index. So sin I by sin R we have considered based on Snell's law. So Rehan, when you write sin I by sin R, you will write as sin itself, right? Rehan is asking, sir, what is sin? It is actually sine. You don't have to write as sin R and sin I. You can write as sin I and sin R. You can just use 3 letters. Fair enough. It's understood. Clear, Rehan?
Some of them did not learn trigonometry, that's why.
Okay. Some of you are sharing, sir, I didn't learn trigonometry. Fine. So unmute Rehan. Rehan, you didn't learn trigonometry yet, or is it something like sine, cos and all is a new term for you?
It's a new term.
It's a new term, don't worry. You learn about the terms sine, cos, tan and all. So as of now, the only thing I can make you understand is there are some scientific terms related to the angle of a particular triangle or any particular angle which we are considering. With respect to that, if we are considering, in the case of a triangle, if you are considering the opposite divided by hypotenuse, it will give the sine theta of that particular angle. You will have better clarity when you learn trigonometry in mathematics. If I start teaching trigonometry as well over here, no, what will happen? It will indirectly convert it to maths class. So here I have to change Manoj Kumar MN Max Tutor. Got it, Rehan? That's why I'm not explaining much about trigonometry. As of now, what is the only thing you have to remember? Sine is a term which we use in trigonometry. So when we are considering the sine theta of a particular angle, we'll consider the opposite divided by the hypotenuse of that triangle. So it will be applied in triangles generally. Got it, Rehan?
Yes, sir.
Because in trigonometry, it's completely of triangles. Trigonometry means triangle itself. Yes. Who was that? Left hand. Sumaya.
Yes.
Sumaya, please do unmute yourself.
So, can you hear me?
Yes, I can hear you.
Sir, can you explain the laws of refraction? Once again, I had some internet issues.
Yeah. The only law you have to remember is angle of incidence, angle of refraction, and the normal at the point of incidence will always be in the same plane. It is the same as in the case of laws of refraction. If you are considering a plane, the incident angle, the refracted angle, and the normal all lies in the same plane itself. It will not be deviated to a different plane. It will be lying in the same plane itself. So for example, do you remember the chart example you might have done in 8th grade? When you have a source of light, when light rays pass through it, the reflected ray, the incident ray, everything will be falling on the chart paper itself. You guys might have done this activity in 8th grade. Unmute Sumaya. If you are considering a transparent medium and if the light rays passes through it and if it undergoes refraction, all these incident ray, refracted ray and all will be lying in the same plane itself. So that is why the angle of incidence and angle of refraction and the normal will be in the same plane, and that is the first law of refraction. And after that we have learned about the refractive index. That is, we can get the refractive index using the Snell's law, that is with respect to the Snell's law, with respect to the angles of angle of incidence and angle of refraction, if we consider the sign of it, we'll get a constant value. That constant value is the refractive index. So that also comes under the laws of refraction. Got it, Sumaya? So don't get confused with Snell's law. You'll learn about it. As of now, you just have to understand from Snell's law, we are taking the values of sin I and sin r in general, and it will give a constant value. That constant n, which is defined over here, is termed as refractive index. So this ratio of sine of the angle of incidence and sine of angle of refraction for the light of a given color and for the given pair of media means multiple mediums, more than one medium. So that is medium. So that will give a constant. That constant is refractive index. Is it clear, Sumaya? Yeah. Fine. Given color means, in the case of Snell's law, we'll consider the color of the light as well. Who was that? So that is why I said, when I discuss the concept of Snell's law, you'll be very confused. As of now, you have to understand when we are considering the sin I or sin r. So for example, the basic idea I'll give you. So guys, do you remember the spectrum of light? Okay, do you know about the spectrum of light? Vibgyor and all. Who was that? Who asked that doubt? Sridhya, right? Unmute Sridhya. Yeah.
Yes, sir.
Sridhya.
You see that point?
What? Come again?
When you were saying that answer, the sound went for 1 minute.
Okay. I was trying to say that why we are considering color in the case of Snell's law is because, do you know about the spectrum of colors where every color which we are considering or every ray of light which we are considering will have different wavelength? Do you know about it? Yeah. So why the color of sky is blue? Do you have any idea about it? Sridhya, are you there? You can say yes or no.
No.
Yeah. So this the color which we are considering, or in the case of the spectrum, every color has different wavelength. Wavelength means what? You know what is wavelength, right?
Yes.
Yeah. So when the color is moving in the atmosphere, it will have different wavelength with respect to different colors. So when we are considering the angle of a particular light ray, we'll consider its color as well. Why? Because it has different wavelength. In Snell's law, we will consider each and every detail of the light ray which we are considering. So that is why it specifically mentioned the light of a given color, because violet will have lesser wavelength compared to that of red. Red will have greater wavelength. Got it? Do you remember spectrum of Vibgyor? So lesser wavelength will split lesser, or greater wavelength will split greater. Like that, it'll have certain properties. So based on that, the Snell's law will be applied. So that is why we are considering it is mentioned of a given color. Understood, Sridhya? Understood? Give me a thumbs up. Yeah. So this is just the basic idea of it. When you learn in detail about Snell's law, you will understand. As of now, the only thing you have to remember, based on Snell's law, we took sin I by sin r. It will give us a constant, that is refractive index. Unmute Mohammed Hero Jilal. Mohammed Hero Jilal, where is Hero Jilal? Can you please raise your hand, Mohammed Hero Jilal? Yes. Yes. Mohammed Hero Jilal, please do unmute yourself. Mohammed Hero Jilal, can you please unmute yourself? Okay. Please give join audio option. Please give join audio option. We don't have an option to unmute, I guess. Yes. So fine. Hero Jilal, can you hear me at least so that you'll get my concept clear? You can hear me, right? Fine. So over here, is the light ray bending anywhere over here? Is the light ray, this is the light ray. Consider this line as the light ray. So the light ray is incidenting from one medium, that is medium 1. Okay, medium 1. and this is medium 2. So is it bending? It's coming straight, right? Without any bending, it's coming straight. Now, I'm considering a particular light ray and goes like this. So is it bending now over here? Hirojlal, is it bending now? Yes or no? We'll communicate with gestures. It's bending, right? That is deviation. Understood what is deviation? If the light ray is not going normally, if it's bending from a particular position or the surface of separation, if it bends like this, it undergoes deviation. So it has a variation in its path. So in that case, we can term it as deviation. That is what deviate means. I hope you got the concept. Yes. So value of the ratio of sine of the angle of incidence to sine of the angle of refraction, that is sin r by sin r, is a constant, that is the refractive index, and I hope you have written it down. So for your reference, I took it again. It's important. In detail about Snell's law and all, it's not required at your level in 10th grade. It's not required. It won't be asked. So this simple general idea of it should be there. You should know the value of ratio of sine of the angle of incidence with respect to the ratio of sine of angle of refraction will give refractive index. You should know that. That is the only thing. You have to keep it in your mind. Suraj Sudesh wants to answer why the sky is blue. Yes, Suraj Sudesh.
It's due to atmospheric refraction, right?
It's cause of atmospheric refraction. The wavelength of the colors are different.
Yes, sir.
Yeah, the light ray is like violet and blue has shorter wavelength cause of that.
Yes, sir. So when it reaches at the end, it just spreads all over.
It spreads all over, yes. And our eyes are more sensitive to blue light than violet.
Yeah.
So even though violet spreads more than blue, our eyes are more sensitive to blue, so that's why we feel like the sky is blue. Thanks for sharing it, Suraj Sudesh. So guys, I hope you have written it down. Let's go ahead. So a ray of light falling obliquely from air to glass slab is shown in the figure. Find out the angle of incidence. Find out the angle of incidence. Who will be giving me the answer? Let's unmute Gershom, right? Gershom over here. Shweta ma'am, yes. First, yes. You tapped it, right? Yes. Okay. Okay. We'll ask. Whom should we ask? Gershom has used to communicate, right? We'll give chances to someone new. We'll call Hosanna Aji Chako, right? Yes.
Yeah.
Hosanna, how will we find out the angle of incidence if a diagram like this is given the question? How will we know the angle of incidence? Oh, here the angle of refraction is given, right? What is this 33 degree? If this is the normal, this will be the region where we can mark the angle of refraction. Then what will be the angle of incidence? Who will answer me? Hosanna went away. What? We'll ask Said. Yes. Hi Said. Do let me know. How will we find out the angle of incidence? Those who know the answer, no, keep your hands raised. Those who know the answer, keep your hands raised. Yeah.
Hello, sir.
Yeah, Said. Please let me know how to find out the angle of incidence. What do you think? What are your thoughts?
You hear me, right?
Yes. So guys, don't think like any particular question which we didn't discuss. If you are making a mistake in it, it's completely fine. I'm taking the guess answers. You can make mistakes. You can say, sir, I'm confused. I don't know. It's okay. It's not something which I already taught and you're not answering. This is a new question for you guys. So you can give a try or else you can skip it. Yes, Sai. Do you know how to find out the angle of incidence? If you don't know, it's fine. Sir, you can say, sir, I'm confused with this question.
Yes, sir.
Fine. So, whom will we ask then? We'll ask Archisha, right? Archisha, Rajesh.
Yeah.
If I don't have to unmute you, you can say, sir, no, please don't unmute me, I don't know. Gestures itself, so that we can save time. So, Archisha, what do you think about the angle of incidence?
I'm not sure.
You're not sure, but you can give a wild guess. Go for it.
I think it's 60.
60. Why do you say it's 60?
Because if you take a right angle, meaning
Very good. The normal will always make a right angle, so that will be 90 degree. Normal always makes a right angle with respect to surface or surface of separation. So it will be 90 degree. Oh, here this particular angle is given. The angle made with the incident ray and the surface is given, that is 30. So we can easily figure out 90 minus 30. If you do, we'll get 60. So that is 30 plus 60 is 90. So smart. Very good, Archisha. So the angle of incidence is 60 degree. Fine. You got the answer of angle of incidence, that is 60 degree. Now why the angle of incidence is greater than the angle of refraction in this case? Who will answer me this? B part. Whom will we call, Shweta ma'am? Jaswin. Unmute Jaswin. Jaswin, what do you think? Why the angle of incidence is greater than the angle of refraction? You can see that angle of incidence is 60, right? And angle of refraction is 33 degree. So over here you can see that angle of incidence is greater compared to that of angle of refraction. Why is that?
Because it's coming from rare to denser medium.
So the light ray is going from rarer to denser medium. In the case of denser medium, what happens? The refracted ray
It comes near to the normal.
bends towards the normal, so the angle of refraction will be lesser. Very good, Jaswin. I appreciate that. So in this case, it is air and glass, so it is from rarer to denser. Air is a rarer medium and glass is a denser medium in this case. So we can consider the angle of incidence will always be greater than the angle of refraction, since the refracted ray will bend towards the normal in the case of rarer to denser. Towards the normal, rarer to dense. I hope you remember it. So please do note this down. This question was there in your board exams. So it's a previous year question. Note it down. Quick. I hope you know the answer. So I'm not writing it again. Know the question real quick. Once you're done, type down in the chat box. Then only I'll come back. Then we'll go ahead with the exam time. So guys, do one thing. We are not gonna waste time. Take a screenshot. I don't appreciate screenshots all the time, but for the time being, figures and all is there, right? So you'll be consuming a lot of time to finish it. Take a screenshot. Write it down in your notebook. Don't be like, sir, I have the screenshot. In the next session, I'll be asking you, everyone will be asked to show your notebook to the camera. So please do note it down right away after the session. So I hope everyone is done with the screenshot. Wave your hands if you're done with the screenshot. Fine. So we'll proceed with the exam time. Yes. So click on the exam tab and submit your responses real quick. In the meantime, Kiran sir will make me invisible. Once you're done, type down in the chat box. Discuss the answers real quick. Easy 5 questions, right? Fine. So the first one. So this time, I won't be giving you a chance to answer. I'll be showing the answers directly, straight away. With the question, you'll have the answers as well. So those who didn't submit, we are noting down the names. Don't submit your answers when I'm discussing it. So the first question. When a ray of light entering obliquely from one transparent medium to another, its path undergoes a deviation. Deviation. What will happen to the deviation? One transparent medium to another. It undergoes a deviation. Where? On the surface. At the surface of first medium? No. At the surface of separation for sure. At the surface of separation, it will undergo deviation. Now, next question. While entering from air to glass, the refracted ray deviates towards the normal because air is a rarer medium and glass is a denser medium when we are comparing air and glass. So, when the ray of light is incident entering from air to glass, the refracted ray bends towards the normal. So, I hope you know it. So, the first option is the right answer. Now, next question. If an incident ray passes through the normal, it doesn't undergo deviation or refraction in ideal cases. What will happen if we have two mediums and the incident ray incidents directly towards the normal? Will it undergo any deviation? Will it undergo refraction? No, right? So the statement is true. It's not false. The statement is true. Now, the angle of incidence, the angle of refraction and normal are not in the same plane. Not in the same plane. True or false? What do you think? Everyone knows that for sure. Sir, easy questions. Obviously, statement is false. It is in the same plane. Next question. Constant from dash low is known as refractive index. Everyone is like, sir, please don't put such easy questions very easy. Everyone answered it very easily. Obviously, it's not Faraday's law. We know it's none other than Snell's law, not Newton's, not none of the above. How many of you keep click none of the above? So, for today's exam, everyone got 10 on 10, right? So, before we wind up, any questions, concerns, queries? Any hand raises, ma'am? No, right? Fine. So, please don't forget to revise, guys, and don't forget to write the question in your notebook. I gave you a question to take the screenshot, right? Fine. So, Rijini is like, thank you, sir, bye. I'm not going. I'll sing a song. Fine. Yes, Sridhya, what's your doubt? Go for it. Sridhya, have a doubt? Advait is like, sir, no queries, please leave. You want to answer, right?
What is the first one?
For what? For which question? This one? At the surface of separation.
But then, sir, I got 8 out of 10. I know where I lose.
You might have clicked any wrong option. I'll check it. I'll check it and let you know. Don't worry. Sridhya. Okay, your roll number is S2217. Yeah, I'll check it. Don't worry.
Yes.
Yeah. So in the next class, you make me remember, sir, which question I made a mistake. I'll check it. Fine. So that's all for today, right? So that's all for today. If you got all the concepts, give me a double thumbs up to the camera, everyone. So please do revise whatever we have learned. Stay healthy, stay happy. Fine. Bye bye.